William, Ivy, Mia, Caitlin, let's do this. All right, here we go. First, today we're going to talk about solving absolute value equations. Before we need to do that, we need to remember what absolute value is defined to be and interpret that based off of the questions that here. So essentially, absolute value is the distance from 0 on the number line. So if I have the number 2, distance from 0 is 2. If I have the number 9/2, the distance from 0 is 9/2, that measurement. If I have -3, that distance from 0 is +3. Okay? So distance from 0 is kind of the definition of what an absolute value is. So when we go to evaluate problems with absolute value, say that's plus. Hashtag I don't like that tip. When we do this, we don't just change everything to a plus, right? What we do is we evaluate the stuff on the inside as much as we can. So in that would be a -7 inside, 2 plus 6. And then we look at the inside. Absolute value of -7 is going to be +7. So we end up getting +7 times 2 when we go to do this problem. Okay? We get 14 plus 2 plus 6. Keep going. 16 plus 6, which would be 22 today. So the answer to this problem would be 20. Skip this. Okay. One of the situations when we deal with absolute value, when we reverse it, instead of evaluating is kind of going forward. Solving is kind of going backward. So when we turn around and solve it, we need to think in reverse. So we have to think what values of x can go inside this expression so that the answer is 3. So in order to do that, Cameron, what we need to think about is what numbers are working there. So what numbers are 3 away from 0? Because the definition is distance from 0. So like if I go from here, I go to the right, 3 away from 0 is going to be +3. So we get one answer. We get an answer being x is +3. But we also have another way we can go on the number line to get 3 being the distance from 0. So that distance from 0 could be -3 could have a distance from 0. And the answer could be either of those questions, meaning if we take those two and we drop them back in absolute value equation, this makes a true statement. Okay, that makes a true statement. If we drop this in absolute value, it also makes a true statement. So we actually get two answers when we're talking about this absolute value equations. Okay, so we can create an algorithm or a method for solving this. So when we turn around and we do this, we split it. One, we say that it's a positive side, and the other, we say that it's a negative side. So again, dealing with the fact that we've got two ways we can walk from 0 to get the same distance. We have two potential directions to go when we're talking distance from 0. And we only can do that when the absolute value is all by itself. If the absolute value is not all by itself, we have to do something different. Okay? So here we go. When we're solving this problem, here's an expression, an equation. We don't have the absolute value by itself, so we can't just straight up split it. But what we can do, we can isolate the absolute value here. Step 1, isolate the absolute value so we can add 13 to both sides. And then we get x minus 9 equals, today that would be 5. Okay? And remember, absolute value is distance from 0, so we have two potential ways from that center point we can go. We can go to the right and we can go to the left. We do that, we get one statement that is like the negative side, and we get another statement that is the positive side, meaning we can go opposite ways when we're talking about direction here. And then we can turn around and solve it. So what winds up happening is we end up getting two answers. Okay, we wind up getting two answers. One is x equals 4, or the other is x equals 14. Both of those answers work if we place them in that equation. So like if I was to take 4 and dump it in, that's going to make a true statement because we get absolute value of -5 minus 13 equals -8. Is that true? Well, absolute value of -5 is 5 minus 13. That's going to be -8. So it's a true statement. We can turn around and do the same thing with 14 and get the same answer. Okay? We end up getting a true statement. So we have two answers for this potential situation. A little bit different when that's an inequality, but today we're just focusing on equations. Here we go on the next one. So we have an absolute value equation. Those are not parentheses. Since they're not parentheses, we cannot do this. That would be bad. We can't distribute it. The reason why we can't distribute it is because it's not parentheses. It's a whole different representation of a different operation, and it's a really fancy one. It means this stuff in there, that distance, that stuff's distance from zero, that's what we're trying to evaluate. So it's a whole different representation than this guy with parentheses. Okay, so just be really, really safe and careful and aware that it's very, very different. So when we turn around and do this, we need to isolate that absolute value first, meaning get it by itself. You have to understand that that operation that's squeezed in there is a times, just like a number written out in front of anything else. So like 3 parentheses, that would be 3 times. This is 3 times, but it's 3 times a special operation that's trapping that x, 5x plus 2. Okay, so we have to deal with it in a unique way when we have these vertical pipes. Okay, so first we got to get that absolute value by itself. So we're going to divide by 3, get it by itself because it's times 3. We divide by 3 to get rid of it. And then we have this. Now we can split it into 2 different things representing that stuff in there. That stuff's distance from 0 is 6, meaning we could have a positive on the number line or we could have a negative on the number line. So there's 2 different problems. So we can turn around and represent that there's the negative on the number line going to the left. We get rid of the absolute value and drop a negative in there, or we can have the same exact stuff, right, where then the distance from 0 is a positive. Okay, distance from 0 is a positive and negative. Now we can solve 2 separate problems. When we do this. So 6 minus 2 is going to be negative 8, divide by 5, divide by 5, and we get x is negative 8 fifths. Or we get another scenario, minus 2, 5x equals 4, divide by 5, x equals 4 thirds. Oops, 4 fifths today. X equals 4 fifths. So we have those 2 numbers. There we go. That would be our answer. We don't have to graph it unless it's an inequality. Okay? 2 numbers. Here we go. We've got another scenario where we're going to end up having 2 numbers on the next problem. So again, we don't want to distribute that negative 2. We want to dig out the absolute value thing all by itself and then move from there. So we're going to subtract 18. So what I didn't do is when we turn around, this is kind of similar to doing this problem, right? This problem right here, instead of x, we have this absolute value stuff. The problem at the right, to get rid of that x, we would first subtract 18. We're going to end up doing the same thing over here. You got to kind of view this as a single entity until we get to the point where we split the equation. Equals negative 10, and then we divide both sides by negative 2, and we get y minus 7 equals 5. And now we can turn around and split this. Absolute value distance from 0, but only when the absolute value is by itself can we split it. Okay, distance from 0 represents 2 different sides of the number line that we need to have. We have the negative side, or the negative way of going to get the distance, and the positive side. Turn around and keep solving them. Y equals 2, or 7. Y equals, that is 12 today. So we have 2 answers. We have an answer, y is 2, or we have the answer and the solution, y is 12. Okay, so let's do one more before we move on for the day. This one, we're going to dig out that absolute value, plus 2, y minus 8 over 3 equals 7, times 3 to, absolute value. It's 21. Again, now that the absolute value is by itself, we're going to turn around and split it, representing that the distance that thing inside is from 0 on the number line can go to the left or to the right on the number line. And we turn around and keep solving. Y equals negative 13 today, or y equals 29. These are 2. All right, peace.